So I'm starting the recording and we can start. Okay, so I hope you guys revised the old concepts. And yeah, we're gonna start. I'm gonna see according to your answers. Okay, so spring mass systems. Now, for those who took my Thursday's class, they remember that I made a spring system, something like this. So I had this wall and I had a spring, right? And there was a dotted line here. And this is our little box. Now let me make it, I mean, it's not a box, but we're making it as a box. Okay. Let's make the extended version. Okay. Now I have somehow displaced it by any means. That's not our concern. We're only concerned about the fact that I have displaced it in this direction. I mean, that's the only direction we can displace it anyway. So this is my box, right? And this is the normal line. This is just to give you an idea of how much I have displaced. Okay, can anyone tell me what is the direction of my displacement? Is it left or is it right? Let's see your concepts. Come on, tell me. What is the direction of my displacement? Let's see who can answer that question. Exactly, towards the right. That should be obvious unless anyone has this weird confusion, but that doesn't matter. Okay, so I can make this arrow towards the right, and this is my displacement. And I also know that since I have displaced in this direction, there also must be some kind of force. I mean, right, I have a force, that's why I have displaced it. It's not like there's a, a natural phenomena here. Okay, so this is the direction of my force. I can make a letter F here, and I can write a letter X here. This is my displacement, and this is the force. Okay, now, for those who know how springs work, if I displace this thing to the right, and I stop, I mean, there's obviously a limit to how much I can extend this spring. It's not like I can infinitely, endlessly, continuously, kind of extend it. It's obviously gonna stop at some point. And this is that point. Now, what do you think? Where is this box gonna go? Like when I have full extension and when I release it, is it gonna go towards the right or is it gonna go towards the left? What do you guys think? Exactly, the left, because that's our restoring force. Now, when I release this, if it's gonna, kind of race towards the left, I can say that that's the direction of my acceleration. Okay, let me use an arrow. So this is my acceleration, right? This is the direction of my acceleration. So I can say that this is the small a. And since we have displacement and we have acceleration, I can say that this system is an example of simple harmonic motion. Okay, now we know, okay, can anyone remind me, what is the formula of simple harmonic motion? Yeah, what is the formula of SHM? The basic formula, not this formula, like the basic formula. Can anyone tell me? What is the formula of my simple harmonic motion? Hey, come on, guys. Okay, so it's not a K, it's minus omega squared. So its acceleration is equal to minus omega squared x. This is my formula. Did you guys forget it or something? Okay, this is the formula of SHM. Never forget it. SHM. I don't even write it. Okay, now we're gonna make a formula for this. Can anyone tell me what is the formula of force in spring systems? No. The formula for force in spring systems. Yeah, Kx. So I have F is equal to Kx. And if I have displaced towards the right, and I have a force that took it to the right, I obviously know since it's going to go to the left, there's a force there as well. So can I say that this is F is equal to Kx, this F, and there's an F acting towards the left, and that's F is equal to ma. And both of these forces are equal. If you're wondering how, Newton's third law, every action has equal and opposite reaction. So this is my action, and this is the reaction. So I can say that both of these F's are equal. I can say that Kx is equal to ma. Now, can anyone tell me, am I correct? What do you think is missing here? Is something missing here? Also, don't forget that this is SHM. Keep the fact that this is SHM at the back of your brains. Now tell me, what did I miss out here? There's something that I missed in this formula. Okay, what about the rest? Exactly, the direction. Because I know that A and X, they are opposite. Now it's your choice. You can write minus here, you can write minus here, but according to my choice, freedom of choice, I can say that this is minus Kx. Now there's a really cool thing we can do now. This is A, this is M, this is K, and this is X. So I can say that A is equal to minus K over M X. Now, if you actually compare these two formulas, you're gonna observe that these two are the same, except this thing is my omega squared. So can I say that K over M, this is omega squared. So whenever you have any kind of situation and you wanna find out, let's say you don't know, you cannot identify with this, that this is SHM. Now you can use the formulas and you can derive this. And if you get a formula that kind of matches the original SHM formula, you are gonna be sure that this is SHM. So my omega is gonna be under root of K over M. Now don't forget this since this is gonna be used a lot. Okay, if I wanna ask you, express the time period. Okay, express the time period. Okay, Eliza says, wasn't it minus K? Okay, listen, isn't it minus omega squared? And isn't it minus K over M? So if there's minus minus on both sides, won't they cancel out? Exactly, they cancel out. So, I mean, I don't even need to write the minus. Yeah, so if I say, what is my time period? Now, some of you might get confused, but those who know the formulas, can anyone tell me what is the formula for omega? And I hope you know that this is angular frequency and not angular velocity. So what is the formula for omega? Come on, yeah, 2 pi over t. So the formula for omega is 2 pi over t. Now I can easily find out the time period. How do I do that? How do I do that? I'll just, make this the subject. So it's gonna be 2 pi over t is equal to under root K over M. And then I'm gonna end up with 2 pi. 2 pi is gonna come here, and it's gonna be under root M over K. So let's circle this. This is the time period. Now, if you guys are confused on how I got this, I mean, you can ideally just move this to the bottom and this above when you take this to that side. And you take the t to that side, and basically you get this. I hope no one is confused about this. Is this clear, guys? Are you guys clear about this? Okay. That's great. Now, I know that omega, okay, let me just make this smaller so I can derive another formula. Okay, let's make this. Okay, let's move this to the left. Now you know that omega is not just 2 pi over t. You know that is also omega is also 2 pi f. So omega is 2 pi f, and I can say that 2 pi f is equal to under root k over m. So my frequency is going to be f is equal to 1 over 2 pi under root k over m, and that's my frequency. Now you have two formulas over here. Okay, note this down, and I'm going to tell you something kind of cool. Okay, tell me one thing. You know that every spring has K. What if I say, what if I increase K? What's going to happen to my spring? Let's say I increase K. What happens to the spring? What do you guys think? If I increase K, what's going to happen to the spring? Well, not exactly. Yeah, Abdul Wasi, that's true. It's going to become more stiff. So it's going to be difficult to extend. It's going to become more stiff. And if I decrease it, then it's going to be, you know, what Elisa said, it will extend more. But for now, it's more stiff. Now, we know that this thing happens. Okay, check this out. So I know that according to this formula, okay, so according to this, T is inversely proportional to the under root of K. So if I increase T, K is going to go down. And if I decrease T, K is going to go up. Now, in this scenario, if I increase a time period, right? If I increase a time period, or if I decrease it, okay. So if my T becomes lesser, K is going to go up. Or if my K goes up, my T is going to go down. So it's just an interesting relation that you can derive from these formulas. So, you know, if I suddenly decided to use a stiffer spring here, my time period would be lesser. And if I used a less stiff or a spring with a smaller K, then I would get a larger T. So I hope you understand this relation. And that's it for the spring mass systems. Now, when you guys are done noting this down, tell me so I can erase this. Okay, what about the rest? I just have 3 answers. Okay, I'm gonna wait a sec. I'm waiting, don't worry guys. Okay, so I am gonna erase this. Now, this is where it gets, you know, this is where SHM starts, you know, coming to the climax. Energy oscillations. Now, I am gonna introduce the concept of energy, and I'm gonna place that into SHM. Now, you've studied energies in O level and AS. Can anyone tell me what is the formula for elastic potential energy? What is elastic potential energy? I mean, that's gravitational potential energy. I'm asking you elastic potential energy. You know that it's going to include displacement and the constant K. Okay, if you guys don't know, that's completely fine. Yeah, 1 over 2, except you missed the square. So it's 1 over 2 kx squared. Yeah, Kainat, your answer is correct. So it's going to be 1 over 2, no problem, kx squared. So never forget it. And I know that Okay, so I know that there's another formula for kinetic energy. So, oh, why am I writing it? Okay, it's Ke. So kinetic energy is gonna be 1 over 2 mv squared, and everyone knows it. Okay, now we're gonna place these into the SHM. Now mind it, I'm starting from the mean position. There's a reason why I taught you the formulas for X and V for the mean position and the peak position. But right now, we're talking about the mean position, not the peak position. So make sure you clearly mention this so you don't get confused. Why are the formulas for V and X different? Okay, now I have taught you displacement time graph and velocity time graph last week. Can anyone remind me what is the formula for X and what is the formula for V? Keeping in mind that we are at mean position. Come on, guys, did you forget it? Yeah, A cos omega t. But it's not the small a, it's the capital A. Don't forget it. Kainat, is that for velocity or is that okay? Mention for what you're for. Yeah, mention if it's for X or V because I cannot identify it. Okay, yeah, that's great. So A sine omega t, A sine omega t, and omega A cos omega t. So Legina, I think you mentioned that thing for displacement. Don't forget that for mean position, displacement is sine and velocity is cos. Okay, so now we know that we have these two formulas. Now, what I'm gonna do is I'm gonna make, okay, let's place these things into this. So let's start for EPE, okay, E dot P. I know that this is 1 over 2 kx squared. Now I know that x is a sine omega t. So I can place it in there. I can substitute that. So it's going to be, okay, let's use a red color. A sine omega t. Now I'm going to square it. And I'm going to get 1 over 2 k a squared sine square omega t. Okay, now this is the part where if you miss my word, you're going to get left behind and you're going to miss the concept. So make sure you're attentive. So I have 1 over 2 ka squared sine square omega t. That's a lot of math, so get prepared. Now, ke, 1 over 2 mv squared. 1 over 2 m omega a cos omega t squared. Oh, by the way, you see this 2 here? Now, you guys, the bio students might get confused a bit. So in A levels, in math especially, we don't write sine omega t squared. It's better or it's preferable for us to write the square here. It doesn't mean that it's sine squared. It means that it's sine omega t squared. So don't forget it. I'm still going to write it as a side note. So, because it is kind of new. Okay, let me make this smaller and eligible. Okay. Okay, so now I know that this is going to be 1 over 2 m omega square a square cos square omega t. That's a lot of squares. Okay, now we are gonna do something. Now I'm gonna make all of this smaller and I'm gonna ask you some questions. Okay, let me just. Okay, let's bring it up. Now, again, for those who haven't studied bio, you kind of need to know this. And for those who study bio and don't study math, you need to know this. For those who study math, it's going to be a kind of a recap for you guys. Okay, now tell me, just a second, let me move this. Okay, so if I make a sine graph you guys know what it's going to look like. So a sine graph, you know, if it's just sine theta, right? If it's just sine and sine omega t or just sine, right? This is just sine. So a sine graph looks something like this. Let me make it. So this is my line and this is a sine graph. Okay, yeah, this is a sine graph. And if you've seen our velocity and displacement graphs, you probably know that this is the shape. Now, if I say that I suddenly decide to put a square on that sine and it's sine square, what is my graph gonna look like? What do you guys think? I know it's a bit hard to place it in words, but I mean, it's still possible. So what's gonna happen here? What is sine square gonna look like? For those who study math or for those who know, could you please describe it in words in the chat below? Hey, come on guys. Are all of you bio? Okay, so no, it's not gonna be double amplitude. Okay, no problem. Let me do this. Let me explain you actually. Yeah, Abdul Wasi. Yeah, Wahaj. You guys are right. Check this out. Isn't this plus, right? This is plus and this is minus, right? So if I square it, right? If I square it, I know that this is plus multiplied by plus. Now plus into plus is plus. So plus into plus is plus. That's a lot of pluses. Okay, so this is gonna remain the same. Now I know that minus into minus, is it gonna be minus or is it gonna be, can anyone tell me what is minus into minus? Come on. Yeah, it's plus. So minus into minus is gonna be plus. That's basic math. So yeah, that's gonna be plus, and that's why I am gonna get two peaks. And we're not concerned about their sizes, but they're gonna be the same. So it's just gonna look like this. So instead of one peak, there's gonna be two peaks in the plus, and there's gonna be nothing in the minus. So for the bio ones, I hope you understood it, because if you didn't, you can ask me. Now I'm gonna make this smaller and I'm gonna move it. Okay, that's great, I'm glad. Okay. This is plus. Now we're gonna do the same thing for this, for the cos. Okay, so cos, and let's make a line. Now the cos graph looks something like this. Okay, it's a straight line, LOL. Okay, it's gonna look something like this. What is cos square gonna look like? What do you guys think? Okay, guys, so what is cos square gonna look like? Three peaks. Well, you could say that. Basically, there's gonna be, yeah, there's not gonna be any minus. It's all gonna go to plus. So I'm gonna get this interesting graph that has three peaks. So we have the first one here. Okay, let me move this because there's no space. Okay, that's the first peak, that's the second peak, and that's the third one. So it's gonna look something like this. It's a bit untidy, but okay, let me fix it up. Yeah, you could say that. A W. Yeah, a W. You can remember it like a, you know, W. That's a nice suggestion. Okay. Now make these graphs and I'm gonna write the next thing down. I'm gonna make this smaller again because we don't have space here. Okay, seems nice. Okay, that's great. Okay, so we had our formulas. Let me look at them. So EPE was, the EPE was 1 over 2k a squared sine omega t squared. But now what I'm going to do is I'm going to replace that k. But how do I do that? Well, let's check it out. Now, before, okay, look at this thing. I'm going to replace the k. How do I do that? Check this out. I know that, where was it? Okay, it was in the previous page. So I said that omega squared was equal to k over m. So omega squared was k over m. Now, if I want to write k, I can just say omega squared m, or m omega squared. M omega squared sounds kind of better, so yeah. Let's say m omega squared, m omega squared. Okay, so I can substitute this into this, and I'm going to get a new formula. It's going to be 1 over 2 m omega squared a squared sine square omega t. I hope that makes sense. Okay, now let's make the same formula for kinetic energy, except we already have it in terms of m omega squared. Okay, now you can see it's a very interesting thing. Kinetic energy and elastic potential energy, they have almost the same formulas, except for the sine and the cos. So this one has cos squared, cos omega t squared, and this one has sine. So if you actually look into this, both of them are kind of same. Let's look into that. Now, what we're gonna do is we are gonna make graphs for this. So has everyone noted down everything till this part? All of this, have you noted this down? If you haven't, tell me, because I wanna erase this. Has everyone noted this down? Can I erase this? Okay, that's amazing. That depends on the question. They might, they may not. At least right now, there's no question like this in my mind, but it may come. So don't learn something just for the sake of getting the question. I mean, yeah. Okay, so I have erased this. Now I'm gonna move this stuff to the left, and I'm gonna make a graph. Okay, this comes here, and okay, I'm gonna make a graph of energy and time. Let's make another arrow for this. Okay, so y-axis is energy, and x-axis is time. So this is energy, and this is time. Now, I'm gonna make some curves. First of all, do you think that this graph is gonna be only in the positive, or is it gonna be in the negative too? What do you guys think? After everything that I told you, do you guys think that it's all gonna be in the positive, or this graph is actually gonna enter the negative region as well? I just have 3 answers. What about the rest? We have 17 people here. Come on. Yeah. Okay. That's the right answer. That's great. I'm glad no one has the confusion. So it's all going to be in the positive. Why? Because it's cos square and it's sine square. And if there's a square on sine and cos, I know that it's all going to be in the positive. Now I'm going to make 2 graphs, and I'm going to ask you which one is which. First of all, we're going to have a total energy here. This is going to be E max. This is the greatest energy. So I'm going to make a line, and I can't go beyond this line. Mind it, you can never go beyond the total energy. Okay, let's make the curves. The first one goes like this, and then like this, and then like this. Okay, now let's make the second one. Second one, we're gonna use the green color. Like this. Like this. And like this. It can be a bit confusing, but if you understand, it's not going to be confusing. Okay. Is the green one kinetic energy, or is it the elastic potential energy? Okay, that's right. The green one is kinetic energy. The green one is Ke, and the red one is EPE. And the orange one, this is our total energy. This is the total energy, ET. We're going to talk about it really soon. I mean, now. Okay, now if you guys are kind of confused about why is it that this is the kinetic energy and this is the EPE, look at the the formulas. This is cos square omega t, and you know that cos square, or cos, it starts from this, and sine always starts from this. Or we know that this is the mean position, right? Like we are talking this whole thing in the mean position. Now you know that when I'm on mean position, my velocity is gonna be the maximum, right? So if velocity is maximum, I know that kinetic energy is also gonna be maximum, right? Now remember, this is elastic potential energy, so we're not really talking about the pendulum maybe, but this is also a good point. But the general answer is this is cos square omega t. That's why this is kinetic energy. And this is sine square omega t. So that's why this is EPE. Now, let's write the formulas. I'm going to make this graph smaller. And the formulas as well. Okay, so here goes our graph. I hope everyone understands the graph. If you have any kind of confusion. Okay. Okay, Aima, I'll answer your question. No worries. By the way, we have 2 minutes left. I just checked. So right after I answer Aima, we're going to end the meeting and we're going to start a new one. Okay, Aima, tell me one thing. You know that Ke is cos, right? That's true. You know that. Now, you know that cos is like this, like if I make the normal cos, right? So if I say cos squared, you know that this orange thingy, it's not going to be here anymore. It's going to go up. So it's going to be like this, right? This is going to be your new cos graph. Now, my point was, you know that cos always starts from here. Now, how can I prove that sine doesn't? Okay, let's make sine. I know that sine is like this, right? Now, if I square this, I'm only going to bring this thing up. This point stays down here. So you know that sine, it always starts from the zero, no matter the square, no matter it's square or it's not square, sine always starts from zero. But cos, it doesn't start from zero. I hope that makes sense. Okay, that's amazing. So yeah, that's great. Take it, no problem. Take a screenshot, and I'm ending the meeting because it's 39 minutes up and we have to start the next meeting. Okay, I hope everyone has made this. If anyone hasn't made it, you can tell me. Like we literally have 30 seconds. Okay, so I'll assume that everyone has noted it down, and I'm gonna end the meeting. Okay, I am gonna erase this, and I'm gonna explain it in other words. Okay. Basically, what you guys need to remember is that total energy is equal to KE plus EPE. Now, before I get back to that explanation, I want you guys to know something, that is ET. Now, no problem. I'm gonna tell that a bit later. So I know that kinetic energy is 1 over 2 m omega square a square cos omega t, cos square omega t. And I know that EPE is 1 over 2 m omega squared a squared sine square omega t. Now, we know that this thing right here, it's common in both of the scenarios. So I can say that 1 over 2 m omega square a square is equal to cos square omega t, cos omega t squared plus sine square omega t. And the other day I taught you that this whole thing is going to be 1. So we're going to get 1 over 2 m omega square a square. So this whole thing, this is going to give us 1. This is 1. I hope you have no confusion about this. Now, I know that total energy is 1 over 2 m omega square a square. Right. Let me make this smaller. I hope no one is confused about the formula, because that's like basic stuff. I mean, no problem. If you do have a confusion, you can ask. Okay. Now let me explain in terms of the box that I made earlier. Now, just remember this. Total energy is always going to be equal to kinetic energy plus elastic potential energy. Now, my point was, look at this point. You know that when kinetic energy is maximum, EP is minimum, right? So elastic potential energy is 0 and KE is maximum. But when you come to this point, you're going to notice that kinetic energy becomes 0 and elastic potential energy again goes up. Okay, let's choose a random point. This point. EPE is 0, kinetic energy is max. So what I want you guys to understand is whenever you have kinetic energy or elastic potential energy, and one of them is max, just know that the other one is not gonna exist. It's not gonna exist at all. Do you guys understand that? Okay, I'm gonna explain you through this example. It's just a point that you guys, this is something that I tried to explain heat loss. Look, I understand there's a lot of factors in this scenario, but we just don't care about them at this point because right now we're literally just concerned with ET, KE, and EPE. Yes, at higher levels, you know, when you go in the university, maybe in the future chapters, we might consider that. But right now, we're not concerned about heat loss. Literally, we're not concerned about anything. Yes, that's definitely going to make a difference, but not in A levels. Okay, so I have this spring and I have this box. Now I have a simple question for you guys. This is going to make a little click maybe, depending on how you perceive it. Okay, I have this plane. Now, you know that at a certain point, I have maximum extension, right? I cannot go beyond this point. So I can say that elastic potential energy at this point is maximum. It's max. And tell me one thing. Do I have any kind of velocity at this point? I know that this is literally the last point. It cannot go beyond this point. Do I have any kind of velocity at this point? What do you guys think? Exactly, I do not have. So KE is gonna be 0. And that's why, just for this critical point, I can say that total energy is gonna be equal to EPE. Now let's look at this point on the graph. I have EPE. Look at this point. Let me make it in a green color. This point right here. Okay, that's not visible. How about this color? Okay, this is the point that I'm talking about, point A. I know that my curve coincides, it intersects the line. So just for this point, my total energy is gonna be equal to EPE. That's what I wanted you guys to understand. Just to get an idea of how EPE and stuff works. But yeah, I hope that made sense. Okay, did that make sense? Okay, great. Now, we can move on to something different. It's gonna be related to this, but it's gonna be a bit different. Now, I have a graph. This is my graph. But now we're gonna make a different graph. What if it's somewhere else? Okay, so US man, if it's somewhere else, right? If it's somewhere else, basically just follow this formula. ET is equal to KE plus EPE. If your KE is 0, you know that automatically ET is going to be equal to EP. But if you have some KE and if you have some EPE, both of them, basically the total of KE and EPE, it's always going to remain the same, right? The total of these is always ET. That's just what you're supposed to know. Okay, let me make a graph over here. Now this is a new graph and it can be a bit confusing. And this actually comes in the paper to draw. So pay attention. You do not want to miss this one because it is important. Let me erase these extra arrows. Okay, in the center. Now, I'm gonna make 2 curves. The first one is gonna be like this, and I hope it's a nice curve. Let's kind of erase this. Okay. It's gonna be a uniform curve. I mean, a curve is non-uniform, but it's gonna be a nice curve. And then there's gonna be another curve. And we know that both of the curves are gonna be opposite. So if one is 0, the other one is gonna be max, because that's just how kinetic energy and EPE work. Okay, that's how our graphs are gonna look like. Now, what you need to make sure is if your point is here, both of them should be at the same spot in terms of vertical. And I made a little mistake here. I have to make it at the same level as well. I'm just gonna use some white to fix it up. Okay, it has to be at the same level. Don't forget that. So something like this. And one more thing. I told you before that the total of these two is always going to be the same. So I'm also going to have a line. It's going to be a straight line over here. And this is going to be my total energy. And you have to make sure that none of your graphs, not the red one, not the green one, it shouldn't go above the blue line, because we know that kinetic energy plus EPE, it's gonna give you total energy. It shouldn't go up, nor should it be down. So the blue one is my total energy. Okay, can anyone tell me the red one? What is the red one and what is the green one? which one of these is kinetic energy and which one of these is elastic potential energy? What do you guys think? Okay, now let me explain you something. Now this graph and that graph, they are different. So this one has more to do with our normal simple harmonic motion. Why? Because I forgot to mention something and it might have played a role here. So y-axis is energy and x-axis is displacement. So if my displacement is 0, I know that this is the mean position, right? And you know that at mean position, your velocity is the maximum. And if your velocity is maximum, obviously my kinetic energy is also going to be maximum. Does that make sense? So that's why this is going to be EK, and the green one is going to be EPE. So this is just for the normal SHM, right? But this rule, it stays the same. If kinetic energy is 0, EPE is going to be max. And if kinetic energy is max, EPE is going to be 0. Now, I know that this is going to be minus A, and this is going to be plus A, just like the old days. Minus amplitude and plus amplitude. This point, since this is where my total energy is, this is going to be 1 over 2 m omega square A square. So yeah, and also don't forget this rule. Don't make your lines higher than this. Okay, now I'm going to select this. In fact, I don't need to select this. Okay, if I look at this point, let's look at this point. What do you guys think? Can I say that at this point, kinetic energy and elastic potential energy are equal? So I can say that this is the point where kinetic energy and elastic potential energy, they are equal. And we are going to derive a new formula. It's a small one, so don't worry. Okay. Now, if I make a dotted line, there's something cool that happens. Now let's use an orange color. If I make a dotted line, now since my graph is handmade, it's not precise, this point right here, this should be the half of total energy. So don't forget it. If you make a dot here and you elongate it, to here, you're going to notice that this is 1 over 2 ET. This is half the total energy. Don't forget it. Now, I also know that there's some kind of displacement here. And what I'm concerned with is, what is this displacement? I want to find it out. And that's what we're going to find. But to find it, we have to place our values here. Now, I know that EK is 1 over 2 mv squared. And elastic potential energy is 1 over 2 kx squared. Okay, now I'm going to keep x because, that's what I want to find, right? I want to find displacement. So I'm going to keep this, but I want to replace velocity. Okay, can anyone tell me what is the formula for velocity? Which formula do I put here? Can anyone write in the chat? I want to check if you're going to give me the right answer. Come on, guys. Which formula of velocity, or just write the formula down in the chat. Come on, guys. Everything that comes to your mind, write it down. You are forgetting one thing. There's one thing you guys are forgetting. Okay. I want to write a small note here. Don't forget it. Whenever for SHM, for energy stuff, whenever we make graphs, right? for a graph, so whenever I make a graph, I'm going to write it on the next page because there's no space here. Whenever I'm making a graph, I'm going to use a omega cos omega t. But no matter what kind of calculation I'm doing, I am always going to use v is equal to plus minus omega under root a squared minus x squared. Do not forget this formula, the one we did that day. Okay, now since I'm substituting this formula into this, I'm not going to be concerned with the plus minus. So we're going to keep the plus minus because you're going to see why. Because it's going to be squared, so it won't make a difference anymore. So it's going to be 1 over 2 m omega under root a squared minus x squared squared, right? So don't forget it. Whenever we do any kind of calculation, I mean, like this, you know, like derivation and stuff, always use this. But there are some cases where you may use that. But in this scenario, we're using this. 1 over 2kx squared. Now, if I square this, okay, I really want to erase some stuff here. Have you guys noted down this blue part? Because I need space. Okay, I'm erasing the part above. Okay. So nice and slow, and let's erase this. Oh, we messed up the graph. Okay, let's move this up. Okay, it's back up here. Okay, now we can use basic math and derive the formula. It's going to be 1 over 2 m omega squared a squared minus x squared is equal to 1 over 2 k x squared. Now I have 1 over 2 on both sides, so I can simply cancel these out, right? Now, I also know that k, I forgot to add one thing here. We want to substitute k as well. Omega squared was, okay, can anyone remind me the formula? I want to check. What do I put k equal to? I did this before. Come on, guys. What is k equal to? I did this before. What is k equal to? No. What is k equal to? I want to know the formula for k using the formula I mentioned before. Yeah, m omega squared. So I want to substitute this into that. So it's going to be m omega squared here as well. So m omega squared, a squared minus x squared, and m omega squared x squared. Now you're going to see that m omega squared gets canceled out as well. And finally, I end up with a squared minus x squared is equal to x squared. And if I do this, I'm going to have 2x squared. And finally, since I want to find x, I'm going to do x squared is equal to a squared divided by 2. And finally, I'm going to do an under root here. So under root, and I'm going to end up with this. So it's going to be plus minus, and we're going to get x is equal to plus minus a divided by under root 2. So the displacement at this point is going to be plus minus. Okay, now check this out. First tell me, do you guys understand this derivation? Okay, now you see this is a plus and this is a minus. And you can see that I have two displacements, right? Let me show you how. Look at this. I have a displacement here as well, right? So this is going to be plus whatever it is, and this is going to be minus. So a divided by under root 2 and a divided by under root 2. And we finally found this out. Now this comes in the paper it can come in the paper to prove, so you'll have to practice this. And usually for calculations, they do ask you, find the displacement at this point. I hope this makes sense. Okay, so we have done everything we wanted for today. If there's any kind of confusion, you guys can ask me, and yeah, we're pretty much done. I just have to write a short note after this about the thing I said before. So once you're done, noted this down. Once you have noted this down, tell me. Okay, that's amazing. Now, a short note so that you guys remember this. So the note is that only when sketching graphs, like when you need the shape, use V is equal to omega A cos omega T, right? But in the normal cases, use this. So, but unless specified, like unless specified. So unless they specify you, just like we did before, because I mean, it is pretty legit for me to go ahead and use this we in that formula. But if you use this, you're not going to get what I derived earlier, right? So just a short note, and see you guys tomorrow. And by the way, I want to talk about that Microsoft thing. Okay, I understand that it can be a bit hard for some, but don't forget that this Discord thing and all this stuff, it was also new, but everyone eventually understood this. So this Microsoft thing, this is actually much better. Like imagine, I wanted to finish the editing of previous lectures on Sunday, but I couldn't because I had stuff to do. But if we're on Microsoft, I don't need to edit lectures at all. Like let's say this lecture ends, and then the video is going to get uploaded on its own, and you can just click on it and watch it literally anytime you want. So that is why it's better. So it's going to take us a few days to make accounts for everyone. So what I want you guys to do is message Omar. If you go up in the chat in main group, you're going to see that Omar, he's our organizer, and etc. So go ahead and message him your name and the courses you're taking, like A1 physics and A2 physics. Once you do that, your name is going to get added into the sheet, the Excel sheet, and all of you are going to get emails made. And yeah, so when the emails are made, we're going to ask you to download Microsoft Teams, though it's preferable if you download Microsoft Teams beforehand so that it's easier. Anyway, I hope no one has any kind of problems from today's lecture, and see you all tomorrow. Have a nice day, and Allah Hafiz. Bye, guys.